Let's do problem 6, the last question on the practice exam. So when I'm making this video on Saturday night, not on Saturday night because that would make me a loser, but over the weekend, um, we haven't talked about this in class yet, so that's what we're going to talk about on Tuesday. That may have already happened in the past by the time you watch this. So we're talking about the unit circle, so let me draw a picture of the unit circle. Alright, and maybe this thing will even help me draw some axes here. So y-axis, x-axis. Alright, so this is really just a question about practicing with radians. Okay, so radian is a measure of an angle, and so there are infinitely many radian angles around the circle, but just kind of as landmarks, we memorize these important ones. And so let me say what those are. Okay, so the important radian measures, the ones that we memorize, are this angle is pi over 6, this angle is pi over 4, and this angle is pi over 3. Okay, and when I say angle, I mean like if a line were to come out at the origin, then the angle that that line makes with the x-axis would be that many radians. Okay. By the way, so you know that this is the unit circle, which means that the radius is 1. So this is actually the point 1, 0, right here where it touches the x-axis. And these questions about finding the terminal point, what they mean is they want to know what the xy coordinate of the point on the unit circle that corresponds to this angle is. So the point on the unit circle that corresponds to pi over 6 is this thing that's next to pi over 6, whatever that turns out to be. And usually you just have to memorize those. And so let me write what they are. So let me write the familiar angles here. So the familiar angles, I guess 0 is also 1, so just the no angle whatsoever. And then it goes to pi over 6, and then pi over 4, and then pi over 3. Okay, and maybe you've already memorized these on your own, but these are the x and y coordinates of the points in the unit circle that correspond to those angles. And I'm sure we'll talk about how to memorize this in class. This is 0, this is 1/2, this is the square root of 2 over 2, and this one is the square root of 3 over 2, and I meant to write one more. It should be pi over 2. And did I label that? Yeah. Here, this one, pi over 2, is important too. Pi over 2 is this 90 degrees is pi over 2. And the y coordinate there is 1. Now the x coordinates just follow the same pattern but go down because the circle is so symmetric. So this is square root of 3 over 2, this is square root of 2 over 2, 1/2, and 0. So now if I wanted to find the terminal point for any of these familiar angles that I've written, I could just read it off this chart. So pi over 6 is going to be the point x equals square root of 3 over 2 and y equals 1/2. Now I want to do that same thing for this thing, t equals 5 pi over 3, which seems like it's going to be really hard, but it's not going to be. So how do we find that? So this will help to know that this is pi, okay, and this is 0 is the same as 2 pi. Okay, it has the same terminal point. Anyway, it comes all the way back around full circle. So what this is doing here, if you think about this, 5 pi over 3, what it's doing is it's going pi over 3 times. Okay, so pi over 3 is 1/3 of pi. Maybe I haven't drawn the best picture. But here's the first third of pi, here's the next third of pi, here's 3/3 of pi as a whole pi. Okay, and now we split this other little hemisphere into thirds too. Okay, so what is this? This is 4/3 of pi, and this is 5/3 of pi. And good gravy, this is the one, this is 5 pi over 3. 5/3 of pi is exactly what we're looking for. Okay, so what we want to know now are the coordinates of this point on the unit circle that correspond to this angle, 5 pi over 3. And the reason we know it is because, look, the x-coordinate must be the same as the x-coordinate for pi over 3. Okay, so I know that the x-coordinate is going to be, look here, it tells me what the x-coordinate is for pi over 3. It's 1/2. So the first part is 1/2. And now, oh gosh, what do I do about the other thing? Well, I need to know what its y-coordinate is. It's not exactly the same as the y-coordinate of pi over 3, but by symmetry it's just the negative version. And if you look at pi over 3, the y-coordinate is square root of 3 over 2, so that the terminal point for this thing is going to be negative square root of 3 over 2. And that's it. That's done. That was really easy. So this first one is done. And let's look at this other one. Okay, so this one is much easier. So this other one that we're interested in is minus pi over 2. Okay, so minus a negative number just means you spin around the circle in the other direction. So pi over 2 is 90 degrees, and minus pi over 2 is just 90 degrees spinning clockwise. So it's this. And it's really, we don't even need to look at the table to figure out what this one is, right? Because this is the unit circle and it's on the y-axis. So that means that its x-coordinate is 0 because it's just below the origin. And its y-coordinate is -1 because this circle has radius 1. So that's the point it must be. So the terminal point for this other thing is 0, -1. And we're done with part B. Okay, so let's see how we're doing on time. Doing okay. Let's try one more part. So it says show that this point is on the unit circle. Okay, so how do we do that? Well, what we do is we realize that there's a formula that describes the unit circle, and we will talk in class about how that formula is y squared plus x squared equals 1. And so to show that this thing is on the unit circle, all we have to do is show that when we plug it into that formula, it makes it true. Okay, so let's do that. So what is that saying? That's saying that 25 over 169 plus 144 over 169 is equal to 1. Okay. And it's easy to see that this is true because 25 plus 144 is 169, so this is all 169 over 169 is equal to 1, which is just true, right? And don't take it for granted because we could plug crazy things into this equation that would make it false, but because this really is a point on the unit circle, it makes the equation true. And okay, so we're going to do something similar here for part D. So part D says, find the missing coordinate of this point. And so the star here I wrote is supposed to be like the unknown, but we know that the y-coordinate is -7 over 25. And we're going to use the fact that P lies in quadrant 4. So what does that mean? The quadrants are labeled like this. 1, 2, 3, 4. They go counterclockwise. So it's going to be down here, alright? So what we're doing basically is we're looking at this y-coordinate, which is -7 over 25, and then we're trying to find the x-coordinate that maps to a point on the unit circle. Alright, so let's set everything up. So that number is -7 over 25. -7 over 25. So the question we're asking ourselves is x squared plus -7 over 25 squared is equal to 1, and the question basically is what x makes that true. And so that just amounts to doing some pretty easy algebra and figuring out what x is. So let's let's do this. So we got x squared plus 49 over 625 is equal to 1. So x squared is equal to 625 over 625 minus 49 over 625. And what does that turn out to be? I think I did this in my notes, maybe. Yeah, so this turns out to be, what am I saying here? This turns out to be 576 over 625. Okay, and I didn't know this, but it turns out 576 is just 24 squared. Let's solve for x, and we get plus or minus 576 over 625, and this is the same thing as plus or minus 24 over 25. Now we've got that plus or minus thing to worry about, and that's where we come back to the fact that we know that this is in quadrant 4. 1, 2, 3, 4. Alright. So look, the point that we're looking for is going to be in quadrant 4, so that means its x value has to be positive. And so we're done. So the missing x value is 24 over 25. And that's the end. Great. Exam is over.